A warm greetings to one and all. In this session, let's learn about CPU scheduling criteria. As a part of introduction, let's start with types of CPU scheduling. The first comes preemptive. Yes, in preemptive scheduling, each task has a priority. When a high priority task arrives, it can interrupt a low priority task that is still running. The low priority task is passed and continues only after the high priority task is finished. Now let's have an analogy video for preemptive scheduling. A doctor treating a normal patient immediately passes the current task when a critical patient arrives. As a high priority case preempts the current task. The advantages of preemptive scheduling is it prevents one process from controlling the CPU and better average response time in multi-user systems. It is widely used in modern operating systems such as Windows, Linux, and Mac OS. The disadvantages of preemptive scheduling is it is more complex to implement, it has a higher overload from context switching, it can cause starvation of low priority processes, and the risk of concurrency issues if preempted during the shared resource access. Now let's check out the non-preemptive scheduling. In non-preemptive scheduling, once a process starts using the CPU, it runs until it finishes or moves to a waiting state. The OS cannot forcibly take away from the CPU. Let's have an analogy video for non-preemptive scheduling. It has an ATM scene showing two customers served one after the other. The first customer completes the transaction fully before the second begins, which illustrates the non-preemptive scheduling. Advantages of non-preemptive scheduling is it is easy to implement in an operating system, it has minimal scheduling burden, and less computational resource are used. Disadvantages of non-preemptive scheduling is it is open to denial of service attack, that is, a malicious process that can take CPU forever. Since we cannot implement round robin, the average response times becomes less here. The CPU scheduler chooses a process from the ready queue and gives it a CPU core to run. Queue may be ordered in different ways. The CPU scheduling decisions may take place when a process switches from running to wait state, switches from running to ready state, switches from waiting to ready state, and it gets terminated. For situation 1 and 4, there is no choice in terms of scheduling. It is called non-preemptive scheduling. A new process must be selected for execution. For situations 2 and 3, however, there is a choice. It is called preemptive scheduling. The aim of scheduling algorithm is to maximize and minimize the following. The first comes CPU utilization. It makes sure that CPU is operating at its peak and is busy. Throughput. It is the number of processes that complete their execution per unit of time. Next, waiting time. It is amount of time a process has been waiting in the ready queue. Response time is the amount of time it takes from when a request was submitted until the first response is produced. Finally, turnaround time. It is the amount of time required to execute a specific process. The CPU scheduling algorithm should maximize the CPU utilization and throughput, and it should minimize the waiting time, response time, and turnaround time of a process. Thank you all.